Freefall is up next. Freefall is just a special case of constant acceleration. When in freefall, you, or whatever object is falling, have a constant acceleration, at least on Earth, of 9.80 meters per second squared downward. Frequently we will write this as AY is minus G, where G is just the magnitude of this acceleration, 9.80 meters per second squared. So you'll see me make this use, AY is minus G, very, very often. Now, you may have had another physics class, and you may be wondering, why are you using 9.81? Why are you using 9.80? Isn't 9.81 meters per second squared the accepted value? Yes, at the equator at sea level, we're not really at sea level. It's more true over more of the land surface of the Earth, at least, that it's closer to 9.80. Specifically, right around Pasadena City College, it's 9.7946 meters per second squared. I presume that value comes from JPL or Caltech, but in any case, or possibly from decades of values averaged at Pasadena City College. Either way, we're going to use 9.80. You can use 9.81 meters per second squared. It doesn't generally result in a significant difference, so I will notice that it's a little bit different, and then when I see you're using 9.81, I'll go, oh, well, that's the reason. I'm fine with you using either 9.80 or 9.81. I'm not fine with you taking G to be negative 9.80 meters per second squared. G, as I use it, is just the magnitude of that gravitational acceleration. All right, now what is this actually telling us? Well, it's actually saying that for every second you fall, you go 9.8 meters per second faster. 9.8 meters per second is pretty significant. By the time you hit 25 meters per second, you are going about the same speed as a car on the highway. So you're in that 60-65 mile per hour kind of range. So we're getting almost halfway there. You'd be going certainly 25-ish miles per hour after a second of freefall. It's pretty noticeable. After 2 seconds, you'd be going 19.6 meters per second. So at 1 second, 9.8 meters per second. At 2 seconds, you'd be at 19.6 meters per second. At 3 seconds, see, 3 times, let's say 3 times 10 to ballpark, and then we'll divide 3 times 0.2. So that's going to be 29.4 meters per second, and so on. By the time you hit 5 meters per second, by the time you hit 5 seconds, you'd be going 49 meters per second. Let's see, 40 minus that would be 39.2. Okay, so the speeds really pick up fast, and by the time you've been free falling for 3 seconds, you've already exceeded highway speeds. How far do you fall during those times? Well, we can actually use one of the kinematic equations, 1/2 at squared, to figure out those distances. So how far you would have fallen, you would be 4.9 meters below after 1 second. After 2 seconds, so I'm kind of just making rows here. Let's see, 4.9 times, it's going to be 2 times 2 is 4, so 4.9 times 4, that's going to be, that is going to be 19.6, isn't it? Because we can do that. So you would be 19.6 meters below. After this, I'm going to have to pretty much go to a calculator, I think. Let's see, 4.9 times 25. Yeah, I'm just going to use a calculator for that. Oh, it wouldn't be 25 yet, it would be 3. 3 squared is 9. Let's see, so 44.1 meters. 4.9 times 4 squared would be times 16, would be, letting the rows get out of control here, hold on. 78.4 meters. And 44.1 meters. And 122.5 meters. 122.5 meters is almost getting up there towards 400 feet. About 10 feet is the floor of the building, so this is pretty significant. As it is, 5 meters. 3 meters is roughly one floor of a typical building. So this is like a floor and a half of freefall distance. If you live in a house that's got one of the typical peaked roofs around here in Southern California, and it's single story, you're probably about 5 meters up if you're at the very tip of that roof peak. So it's a pretty significant distance, and you'd be going pretty significantly fast. Kind of like getting hit by a car at 25 miles per hour if you fall off that. So it's no wonder people break legs if they fall off houses. 19.6 meters, I mean, that's almost 60 feet. That's looking at like a 6-story building. So 2 seconds in the air, yeah, you go fast when you free fall. It's pretty significant acceleration. All right, that's it for free fall. See you in the next video.